Solve the following problem. N is a positive integer such that the least common multiple of n and 18 is 180, and the greatest common divisor of n and 45 is 15. How do we go about solving this problem? Well, first, let us write down the prime factorization of 18 and the prime factorization of 180. How does this help us? Well, immediately we can see that there cannot be a number greater than 7 in the prime factorization of n, because then it would show up in the prime factorization of 180. In particular, we can write n equals 2 to the power of a times 3 to the power of b times 5 to the power of c, where a, b, and c are non-negative integers. We can plug this back into our previous formula for n as follows. Now we wish to match up the exponents. The maximum of a and 1 has to equal 2. This implies that a equals 2. Next, we see that the maximum of b and 2 must equal 2. This implies that b is less than or equal to 2. Remember that b is also non-negative. And last, we have the maximum of c and 0 is 1. C equals 1. So now we can try various different values for b. B equals 0. Notice how we're just plugging in the values for a, b, and c. We get n equals 20. So here we use our second condition, which is the greatest common divisor of n and 45 is 15. Well, we see that the greatest common divisor of 20 and 45 is just 5. So this one doesn't work. Now we try b equals 1. Here we get 60. And we see that the greatest common divisor of 60 and 45 is 15. Great. Now just to be sure, let's check b equals 2. Here we get 180. This one doesn't work because the greatest common divisor of 180 and 45 is 45. So b must be 1, which means that n equals 60.